Well, thank you ever so much for joining us. Welcome. For those of you who don't know me, I'm Rebecca Southern, Strategic Partnerships Director at Plymouth and South Devon Freeport. And I do have a croaky throat today, so do bear with me. I apologise. So as a Freeport team, we've been curating these lunchtime webinars over the autumn. Not something we've done before, but the idea is to invite our experts in our ecosystem to come and talk to a wider group about some of the things that are interesting and topical at the moment. And we're really pleased today to have Simon Cheeseman join us from the Offshore Renewable Energy Catapult. He's there waving in the corner. I think most of you probably know Simon. And I won't say anything about ORIC because he's going to cover that in his presentation at the minute. But we as a Freeport team work closely with Simon. He's a font of knowledge on all sorts of stuff. But I'm going to read out his bio in case I get any of it wrong. So Simon is the Celtic Sea Floating Wind Programme. He leads that, driving collaboration across policy, technology and supply chains to accelerate the growth of floating offshore wind and marine autonomy. With extensive experience in both public and private sectors, Simon has been instrumental in advancing offshore renewable innovation and supporting the transformation of coastal communities. That about sum it up, Simon?
That's pretty good. I could recognise me in there, yeah.
Real, that's good stuff. So he's going to share his insights today on offshore wind, ocean tech needs into the future. So he's going to do a talk and we'll have some time for Q&A at the end. But if you want to put questions in the chat as we go, that would be a really good gauge for kind of the areas of interest to pick up on at the end, if that's okay. So over to you, Simon.
Great. Thanks very much, Rebecca. And hi, everyone. So I'm Simon Cheeseman from the Offshore Renewable Energy Catapult. Delighted to support Plymouth and South Devon Freeport with this series of webinars. I'm going to talk to you about offshore wind, bit about the Catapult, obviously, a bit about the market, something about the technology, then focus a little bit on the importance of marine autonomy, and then sort of zoom in a bit on the Southwest and the Freeport. If we've got time, an example project, and then a sort of summary. So I've got plenty of slides. You never quite know who the audience is going to be, so the slides are really set up for people who are sort of interested in offshore wind but perhaps don't know much about it. But I could try and sort of up the tempo a little bit in my sort of presentation, for obviously recognizing there's quite a few people with a fairly good sort of solid knowledge of offshore wind. So first of all, Catapult Network and Renewable Catapult. So there are 9 catapults set up by UK government to establish or retain skills in certain sectors and markets. There's the cell and gene therapy catapult, connected places, which is cities and transport, compound semiconductor applications, digital energy systems, which is about the transmission of energy around the UK, high value manufacturing, medicines, ourselves, and satellite applications. So offshore renewable energy catapult, we look at, as it says on the tin, how do we produce energy offshore? How do we do it as cost effectively as possible? So we're a research organisation. We're about 300 people, dotted about the UK in key locations. And we're designed to work with academia and industry to help develop innovative technology that collectively then drives down the cost of offshore wind. So we've got various relationships around the UK. When we were first set up in 2012, we tried to hoover up as many experts as we couldn't grab them all. Some of them still sit in academia around the UK. So we've got these sort of relationships. In the diagrams on the bottom left there, we do run the UK's national test facilities. Those are based in Blyth, just outside Newcastle, and also up in Aberdeen. And so we test all the big stuff. We test offshore wind turbine blades. That's the picture in the top left. Below that is a drivetrain and what we call the nacelle. So inside the nacelle is the drivetrain, the control system that sits on top of the tower. And a lot of our work now is around sort of the design and support for floating offshore wind. And we'll go into that in a bit more detail in a minute. So Catapult are basically there to help industry to develop technology. and accelerate that development and commercialization. For industry, it's very difficult to get in front of project developers. If you imagine trying to knock on the door at EDF, it's very difficult to find the right person to talk to. So the idea of the Catapult is that we work with you, we can then showcase your technology and bring the project developers to you, either where you showcase your technology at our test facilities, or where we put you on the stage at a offshore wind event and put the spotlight on you, so to speak. And so we do work very much with SMEs. They are the beating heart of innovation in the UK. Probably about 95% of innovation comes from SMEs. But we also work with original equipment manufacturers, OEMs, and, as I said, the sort of project developers. And these are the key areas of focus for the Catapult. So we're looking at next generation turbines. The turbines you might see onshore are probably around sort of 5 megawatts. When you go offshore, we've got our own offshore wind turbine that we provide as an open access test facility. That's around 7.5 megawatts. We're sort of expecting the next generation of turbines to be 15 megawatts, but we are seeing designs now for 20-25 megawatts. So the message is that the industry, the technology is getting bigger, towers getting taller, we're moving further offshore. Very much focused on floating offshore wind. So fixed bottom wind is either consented, built out, or in the planning process at the moment. So to get more consistent winds, we're moving further offshore into sort of floating wind territory, and more on that in a minute. Project pipeline, that's all about streaming the consenting process. So the consenting process for offshore wind is taking longer and longer. Part of that is driven by the consenting process itself, which is a rather ad hoc way of collecting environmental impact data and sort of analysing that. And I've got an example project of where we're trying to sort of streamline that process. Smart operations and maintenance. We traditionally send people offshore to maintain the turbines. We used to have people who'd abseil down the turbine blade to look at the damage, but now we're increasingly trying to look at autonomous systems to do that work, because we don't want to send people offshore unless we really need to have to. Marine energy, we cover wave and tidal energy at the moment, but this presentation will focus solely on offshore wind. And then future energy systems, this is looking at how we integrate maybe offshore wind with hydrogen, look at grid integration, and also sort of decarbonisation of oil and gas. So powering up oil and gas platforms using floating offshore wind technology, and maybe trying to use those instances where either we've got enough energy on the grid, but we still want the turbines to turn, so we can produce other forms of energy and store that, like hydrogen. And then supply chain. We're very much now into supply chain development and helping UK develop a strong supply chain base so that it can respond to offshore wind procurement calls. So just to sort of summarize what we do, test and validation. Don't think of it as only the big pieces of kit. We effectively do anything that's designed to go offshore. It could be a small component within a wind turbine. We can test that on our own wind turbine. We also look at cyber now for offshore wind. We provide a range of engineering expertise. Some of our people have worked offshore or have been at the coal front with project developers. And so, you can either access them through a commercial arrangement with us. Our preference, though, is collaboration. So we work together, and the Catapult put a bit of skin in the game. You as a business put some skin in the game, and collectively we go out to look for a grant to enable us to deliver a project. Research and development, we've got a large R&D team that are looking at all elements of sort of drivetrain technology, reliability, materials around different designs, cables, export cables, subsea cables, control systems, vessel technology, and certainly as we transition into supply chain growth, looking at autonomy and marine autonomy. This is an example of someone clinging bravely to a blade, whilst at the same time we've got something called blade crawler that is inching or spidering its way up the blade, and will take images of the blade and report back, and can even do sort of emergency repairs in situ. The disadvantage of having to inspect blades every 6 months is you've got to turn the system off, lock the rotor, so you're not generating any energy. We're sort of transitioning to a point now where probably it's drones with very sophisticated cameras and fast shutter speeds that are taking pictures of blades, so we can take those images and then look for where the damage is. This is really just a sort of range of our services. So we've got centres of excellence. We've got an operations and maintenance centre of excellence in Grimsby. We run the Floating Offshore Wind Centre of Excellence. We've got our Marine Energy Centre of Excellence in Pembroke in Wales. And then we've got core competencies around the sort of the growth areas I showed you on the previous slide. Regional offices, I run the Catapult's office down in the southwest, down in Cornwall. And so, you can come to us, ask us questions, ask about how you get involved in some of the initiatives we're running. And any of our regional offices can help you with that. I'm especially helpful for that. So do come to me. And then we've got the test assets that we run, and we run those on behalf of UK. And they're there, and we're always updating those. So at the moment, our blade test asset is there to test 100-meter blades. We're now getting orders in for 120-meter blades, so we're expanding the system up to 180 meters. Same with drivetrains. Drivetrains at the moment we can test 15 megawatt, but we're looking to expand that to 25. And so these are the sort of services that we can offer. And it applies to you whether you're an offshore developer, an original equipment manufacturer, in the supply chain, or an SME, or even part of academia. Part of our role is to link up with academia and support industry to develop that innovative technology. So a little bit about the market. In the UK, there's huge ambition for offshore wind. You're probably familiar with the sort of modern industrial strategy, and then that was then a focus down onto clean energy and floating offshore wind. And then we had the Clean Power 2030 Action Plan, which set some pretty significant targets for offshore wind around the UK. So we've got 16 gigawatts of installed capacity at the moment, and the Clean Power 2030 Action Plan gives us a target of between 43 to 50 gigawatts of offshore wind by 2030. That's a real struggle. That sort of equates to 300 turbines going in almost a day. Quite importantly, last year came the Offshore Wind Industrial Growth Plan, and that sets out really the priorities for the UK in terms of what are the things we can do well in the UK that we can make for ourselves. What are the things that we have to go, well, actually we'll never be competitive in that market in terms of price of steel or cost of workers, and so we'll have to acknowledge that we'll have to buy it in. So a very important document, and I'll come back to that in a minute. But we are seeing significant growth in the sector, but at the same time some really big challenges. So we're all aware of the problems out in Ukraine, the impact that's had on sort of cost of fuel and on supply chain, and we're still sort of trying to recover a little bit from the legacy of COVID and the supply chain disruption there. But that distills down to the fact that it's more expensive to operate offshore now, and some projects that perhaps we felt we were comfortable delivering are actually not affordable at the prices that we originally sort of calculated. So we're having to do a rethink there. So that sort of does impact on these targets. So for those of you that like graphs, we've got an analysis and insights part of our organization. So it's about 20 people there. We're doing the number crunching all the time for UK, overseas, rest of the world type market analysis, and looking at how competitive the UK is. We actually take data from probably about 80% of the offshore wind farms that are around the UK and analyze the performance of that data, look at the availability of those systems, and compound that into sort of cost of energy comparison. We do that on behalf of the UK government, and we do that on behalf of the operators that pay into that system. But it enables us to sort of produce some stats and graphs around this. So up until about 2015, offshore wind was very much a European play. The Chinese have quickly caught up and have got more installed offshore wind than we have now, and are at the forefront of developing some very large offshore wind turbines, and where our European turbine original equipment manufacturers have probably got so much business on they can't really cope, and they're struggling to keep up in terms of the increasing size of turbines and trying to maintain some sort of configuration control. There's now a gap in the market, which the Chinese are trying to fill now. So we're sort of on standby as Offshore Renewable Energy Catapult to test those turbines. That's what we'd love to do. But we are holding back while the government decides how to manage sort of security issues and things like that. So it's still a good story around the rest of the world. Obviously, there's been a real stall in the US, and that was a really strong developing market up until recently. But we'll see, growth still going on in Asia and Europe for offshore wind. Floating wind, sort of new kid on the block. There are installed arrays now, small arrays, propping up around the world. We've got 2 in the UK, up in Scotland, and there's one in France, and others around. So the market there, Japan, South Korea, Taiwan, are likely to be core markets. We've seen a flurry of activity now in the Celtic Sea, and 3 gigawatts of leases released there earlier this year. And then in Scotland, the ScotWind leasing round, pretty successful, but is probably hampered by a lot of the sites are a long way offshore. And that means the cable runs are a long way from grid. And so they could be quite expensive. And there's also an issue about, a lot of the power that the UK needs is needed down in the southeast. Yet, offshore renewable sites are dotted around the coast, and a lot of them are predominantly up in Scotland. So the transmission costs add to the cost of a project being developed in Scotland. And we're looking at that through the energy generation subsidy, the contracts for difference. Let's have a look at the technology, some bright, shiny pictures. So, like all things, offshore wind started off onshore. And so we had onshore turbines developed. And then as confidence grew, we slowly started to move into the water, in relatively shallow water. We're blessed in the UK with the North Sea that is relatively shallow. It's got a lot of sandbanks, and originally we thought it'd be a good idea to build out on these sandbanks, and then we realized that they actually suffer from scour. So the movement of the tides would actually move the sand away from the foundations, and so we've moved into sort of deeper water. And with the advent of floating technology, here's a couple of examples of the types of technology. So a tension leg platform, which where the actual platform is tied tightly to the seabed, what we call a semi-submersible. So this sort of platform, 2/3 of it is underwater, but it's got a more conventional mooring system. And then a spar buoy, where probably 70% of the tower is actually under the water, that gives it stability. But that means there's limitations in terms of harbours and ports that can support these various types of technology, particularly the spar buoy. These are traditionally built on their side and then uprighted, but they're difficult to bring back into port once they're constructed. They have to have very deep water. Little diagram giving you an idea of how floating offshore wind turbines are growing in size. So much higher than the Shard now, much higher than the London Eye. And there are some real engineering challenges now with these platforms. We've seen the development of platforms like Kincardine in Aberdeen, and seen some of the problems they get, probably with a bit of vibration in there, accentuated by the sort of the sort of waves that are continually, even you can never get these platforms absolutely stable. There's always a bit of dynamic movement there. And so, the early ones are being towed back to port for repair more often than probably the companies would have calculated in their operations and maintenance strategy. Here's another picture of the development of the system in France, just to give you an idea of the size. As you see, this is a sort of semi-sub design with a lot of the platform under the water. It's coming alongside to be fitted out. And there's the fit out. This gives you an idea of the sort of space that you need, not the cars, but the tower sections, the blades. There's a couple of nacelles there, and the heavy lift big jib cranes that you need as well. So again, this is in France, and obviously this is different design, but this is what the finished article looks like. Again, on a good day in terms of weather. But there will always be crew transfer vessels coming to these systems, pushing up against the ride-on bars, getting the technicians up to the transition piece, and normally there's an elevator to take them up to the nacelle to do the regular maintenance and any unplanned maintenance as well. If you're interested in offshore wind, please do join the free to join offshore wind directory. And again, I'll make these slides available so you don't have to sort of take screen pictures or make notes. But it's worth joining this. It's really good. You can search it either by technology or geographical area or company type. So it's good. And also, there's a lot of free support for people interested in offshore wind. And there's the Offshore Wind Industry Council. They agreed a sector deal with the UK government back in, I think it was 2019 or maybe earlier. But the upshot of that is the government run the energy generation subsidy scheme, the contracts for difference. And off the top of that, we skim off some money to feed into these sort of support initiatives to help develop the supply chain in the industry. And part of the deal is that the UK content for offshore wind is around 40% at the moment, so really low. Most of the work we get involved in tends to be operations and maintenance. And so we've got a target now through the sector deal to increase that to at least 60%. And there's some other embellishments around that's really good. But it enables predominantly the Catapult to run these initiatives on behalf of the industry. I'll draw your attention to this one. This was announced this week. So you can apply for support to a manufacturing activity from between 300,000 to 25 million for a project. We're not the only ones doing these sort of projects. Crown Estates with their supply chain accelerator have a similar sort of scheme, slightly different conditions. I can see Rebecca wincing at that, but we've got other things like Fit for Offshore, which came out of Fit for Nuclear. So this is getting your business fit to apply into procurement calls, making sure you've got the right business processes in place. Wind Expert Support Toolkit, if you're looking at transiting into offshore wind or you're already in and you want to increase your market share, this is a way where expertise will look at your product range, look at the market, the segment of market you're interested in, look at who your competitors might be, and really gives you some great hints and tips on how to move forward there. Launch Academy, we've got a national program for that. That's really taking, so industry will support this. They're put in a technology challenge. We will then support the program, invite SMEs to bid in with potential solutions, and then we nurture those businesses over a period of 9 months. And invariably they get picked up by the industry sponsors, or the most successful ones do, as part of their new sort of supply chain development. Love to run regional versions of that. We've run regional versions in Scotland, down the northeast. Love to run one in the southwest. And then there's the Celtic Sea cluster. So if you're particularly interested in the Celtic Sea cluster, I know there's some members on the call. Just Google Celtic Sea cluster, open up the website, top right hand side there's a button that says join. Very simple online form. It's free to join. You'll immediately get access to the website and a newsletter and a forum that tries to bring together predominantly supply chain companies that are interested in understanding what's going on. And we give you a lot of heads up on both regional and national events and policy change and that sort of thing. So I really would strongly sort of recommend that you join the Celtic Sea cluster. I am the membership secretary, so I would say that, wouldn't I? Let's have a quick look at marine autonomy. So, it goes without saying, offshore work is very dangerous. We don't want to send people off there offshore unless we really have to. Part of the work we do at the moment with marine autonomy is about environmental data collection, and part of that is for consenting and ongoing monitoring. So if we put things into the water, or we plan to put things in the water, we've got to convince our regulators that whilst we might interfere with the ecosystem there, we can actually repair that, or we can mitigate that risk. Obviously, operations and maintenance. So we've got more and more robotics and autonomy systems going into the nacelle. For example, there's a lot of fairly big bolts in a turbine nacelle that need to be kept at the right tension. Used to be the role of a technician to go in there and tweak and crank every one. We now use something called Echo Bolt that actually tells us what the tension is on the bolt. So, we only have to address those that are loosening off. But eventually we're going to get to the stage where we've got, turbines designed by robots that are maintained by robots. That's a long way away, but that's the sort of direction of travel we're heading in. And whilst a lot of our autonomous systems and marine autonomous systems are relatively small, surface vessels and subsea gliders, we do want to get to the point where installation is actually done by either fully autonomous or semi-autonomous vessels. And ultimately, we're really on the track that using autonomy that can operate 24/7, that isn't so weather dependent, that doesn't need to be fed or watered, saves us money in the long run, improves our performance, and I think cuts down on emissions as well. I want to put in a good word for University of Plymouth. We work very closely with them. I've got a sort of office arrangement with them as well. Their Coast Lab enables you to, and here it is here. It's fairly unique, and it's got it can put wind over wave and tidal. These are the wave flaps there. It's got a floor that goes up and down and a gantry that comes across. There's a lot of floating offshore wind developers that are testing there, and also some marine autonomy people. Cyber Ship Lab looking at cyber on maritime vessels. We've now got the equivalent for offshore wind that we have recently commissioned. And then the Simulation Lab, which is a fully representative bridge simulator, where you can look at sort of co-working with other systems and developers, and sort of plan operations and de-risk operations before you actually do it. We've done this for Milford Haven, looking at bringing floating offshore wind platforms there with a bunch of very confident tug operators, who then discovered when they went on the simulator that they lost half of the floating platforms because the combination of wind and tide just wasn't what they expected. So really valuable sort of de-risking opportunity there. Something coming up in the future is the at-sea component testing rig Actor. This is going to be a sort of 30 by 30 1/3 scale floating platform where you can put kit on to see how it really performs out in a realistic sort of salt environment. Back at the Catapult, back in Blyth, we've got something called DARE, the Digital Autonomous Robotics Engineering Centre. We've got our own MET mast there. We've got our own offshore wind turbine. But the key thing is, this is the DARE facility here. We've got these 3 docks, and we've got a digital equivalent of this, VDARE. So you can put your marine autonomous system in the water, and quite often they're doing it, A, to make sure it floats the right way up, B, to make sure it actually does what they want it to do. So we tend to put representative kit in the water. This is a sort of foundation here, J-tubes, anything where you want to take a survey, you want to do an echo sound, take a picture of. We put them in the water there, or actually around the MET mast, and can do that sort of relatively low TRL level work before it goes off somewhere else to do the more mature stuff. I want to zoom into the southwest now and just touch on the Freeport. Back to the industrial growth plan. This gives you the sort of worldwide benefits of offshore wind and the opportunities. I won't go into those in any detail. You can download the industrial growth plan. It's in the public domain, or let me know and I'll send you a copy. Some very good facts and figures if you need to do a bit of market analysis and opportunities analysis in there. It also includes the various clusters we've got around the UK. This is the Celtic Sea cluster. Unfortunately, the circle's too small. The circle ought to go like that and butt up against the Solent. We had to go back to the authors of this report and say, look, there's much more going on in the southwest than you've given us credit for. And they took that on board. And I can send you the updated version of what that looks like. And we've done our own analysis of the companies that are forming the supply chain in that area. So I'm happy to sort of share that. This message that offshore wind is getting further offshore and deeper sites call for floating offshore wind. So floating offshore wind predominantly in the north of Scotland up here, but also in the Celtic Sea here. And this is one of the number of different maps that show you what's going on in the Celtic Sea, with some test and demonstration sites here and some project development areas. So 1 and 3 rather have been leased now. 2 is up for grabs. And then there are other areas, and eventually the development will stretch around Land's End and come back up past the coast of Plymouth, and probably close to the Isle of Wight, if you all remember sort of Navitas Bay and the aspirations there. But just a quick view of the southwest. Southwest has got a lot going on in terms of robotics and autonomy. And I've tried to list what's going on in Devon, Hampshire, and Cornwall in terms of sort of drone activity, development of marine autonomous systems, really strong in Plymouth. Seeing development in Portland now around the old naval base area there. Here's just to enable you to sort of correlate. Here's those project development areas. So the benefit of this area is you've got a lot of organisations that can help with development of autonomous systems, whether they're drones or whether they're marine systems, surface or subsurface. And then the testing ground is probably in Plymouth around Smart Sound, or it's if it's drones, it's Pradamic or the Flix facility at Exeter. And you're proving it can do what it says on the tin before it actually goes out and does it for real around here. Just to zoom in on Plymouth. So Plymouth is the National Centre for Marine Autonomy, and how that translates for us is that we're looking at creating an advanced marine technology hub somewhere in the Plymouth area. We've got things like the FAST cluster, which is the marine autonomy cluster. Whilst it's a UK cluster, it is centred in Plymouth. We're developing a maritime autonomy assurance testbed with NRAL. We've got the existing Smart Sound Plymouth that's already there as a testing ground. I mentioned ACTA, this sort of 1/3 scale platform. We've got things like the Falmouth Bay wave test facility. And then in terms of energy security, which is recognising that offshore wind now is recognised as part of critical infrastructure. There's an obligation for our Royal Navy to protect those offshore installations in the same way that they protect now oil and gas pipes and data cables. So we're now looking at, how do we make these systems easier to protect? How do you fly your submarine around a floating offshore wind platform? How do we ensure that these systems are resilient? So we've got some work going on in that area. And, we're not trying to create overlap, but we are trying to draw in things that exist that can support. So our DARE facility, the Innovations Centre at Appledore, and the Southwest Future Flight Innovation Zone that I sort of mentioned earlier. So, just, trying to give you an impression of very, very quickly, very high level what's going on. All credit to the Freeport. That's well established and continues to, I think, stretch its boundaries a little bit as much as it can, but absolutely vital for particularly floating offshore wind to provide those that sort of quayside capability and manufacturing sheds that the industry needs. And I think for marine autonomy, predominantly based around the Catwater area where they are actually bursting at the seams, there is a really strong, compelling need for more facilities to be able to support the orders that these developers are getting in. In the interest of time, I think I'll skip over the consenting project. I can come back to that. But in summary, we're building out to targets in 2050, looking at up to 100 gigawatts. It's really challenging though. Offshore wind is part of sort of sovereign infrastructure now. The UK government continues to provide incentives, and we've got some pretty big leasing rounds to sort of drive that. Marine autonomy is critical to all that. And I'd just like to mention in closing, Oceanology International in Excel in 10th to 12th of March. The National Marine Autonomy Centre will have a stand. It's all being arranged by the Freeport. Rebecca, you can say whether there's still opportunities for people to pick up sponsorship.
Yes, please contact me if you're interested. Absolutely.
Yeah, great. And then Maritime UK Southwest, Sheldon Ryan, for those that know him, is organising an Ocean Tech Expo, probably centred around Plymouth University with some in-water demonstrations. And that'll be 17th of 18th of June. Have a look on the Maritime UK Southwest website. I'll probably be sort of organising the offshore renewables element of that. So in the interest of time, I'll say thank you for listening. And I saw some questions pop up that I'll ask Rebecca to act as MC for those.
Lovely. Thanks so much, Simon. That's brilliant, as always. So one of them is just a request for you to send the document that you mentioned, and then there's a more detailed question around European turbine manufacturers. Can you see the question in the chat?
Let me have a little look.
The capacity. If not, I can read it out, but it's quite a long one to read.
Yeah, I'm reading it now. Yeah. So European manufacturers can't meet the demand. They're not responding to requests from floating offshore wind developers. So the Chinese see a real gap in the European market. They're itching to get in there. And you heard probably a slightly preemptive announcement about them building a facility up in Scotland. And also there was an earlier announcement, probably last year, I think it was, about one in Italy. Could the Chinese supply chain meet demand? Probably. Yeah. I think for us, whilst we've always had a slight issue with reliability of Chinese products, having the Catapult that could test those products is good. We probably wouldn't necessarily want the control system architecture and the links back to onshore to be Chinese. We'd want that to be, the security to be endorsed through sort of European, UK designs. That's an ideal solution. So while I think we can probably tolerate Chinese manufactured turbines, we want to know what's going on inside the turbine, and we don't necessarily want Chinese technology doing the link up to control systems. It's a bit like the Hawaii mobile phone issue. They probably will set up fabrication in Europe. Yeah, but and again, I suppose it's how do you control that, and that's the debate that's going on at the moment.
Oh, we've got another one that's just popped up, which is about not strictly flow, but letting everyone know about an event coming up on the 28th of November.
Oh, okay, yeah.
So, yeah.
Okay, thanks for that.
Lovely. Anyone got any other questions for Simon?
You can do hands up if you want to, and pop your face on the screen.
Either or.
Yeah.
I've got one if no one else has. That's okay.
Yeah,
oh, hang on. We'll answer another one first. Is there a risk in terms of IP if we're inviting Chinese companies to fabricate in Europe?
Yes, I think there's always a risk, isn't there? And I suppose that that's part of the discussion about how do we contain that. Obviously, there'd be IP within the Chinese design, but at the same time, in terms of making sure that those systems are robust and adhere to the regulations that we've got in the UK, we've got to be able to manage that side of the IP as well. So it's not going to be easy, not going to be straightforward. But we are looking at it. The government is discussing that with National Cyber Security Centre and ourselves. And I suppose that one step forward, we'll probably end up testing large bearings, maybe blades, that sort of thing, and then get on to the turbines. But maybe it's the developers who are approaching Chinese turbine manufacturers and we say, well, we won't let you develop the project unless the turbine's been tested in the UK. Don't know. That's one option. Good question though. How do you think the regional ports are shaping up? Yeah. I think ports could do it. I think we spend a lot of time talking to ports. Celtic Sea did a good job with a port strategy. But ports are funny beasts. They're, some are privately owned, some are, through a commission. They definitely, won't want to disrupt business as usual to take in support to manufacture or fabrication that only lasts, sort of 10 or 14 years. Probably the golden nugget is operations and maintenance, because that goes on for a further, once you put something in the water, you need to maintain it, and that's invariably for at least 25 years, and then you probably repower it and carry it on. So I think the concern is that if we do the test and demonstration development, or whatever comes first commercially, we'll quickly clog up a port. And so a multi-port solution seems to be the elegant way forward. But it's for the ports to work out really for themselves what that looks like. And as the ports get involved, then the supply chain tends to sort of cluster around that port as well. So it's all about sort of infrastructure, logistics, and having good access for some pretty big technology. There's some things that could go straight offshore, if it's chain or something like that. But other stuff has got to come into a port to be prepared to be part of the fabrication process. Do I have an update on the third?
One more about PDAs, which probably the last one.
No, we don't. No.
Very good question.
Yeah. So I think the delay in that one was it's probably a high voltage DC solution needed for that because of its position. The Crown Estate, I think, publicly said that they were doing something in the background to enable that to be leased. But I don't know any more detail than that at the moment. Would GB Energy get involved? Possibly. We've got in the Catapult, we've got a couple of people seconded into GB Energy to sort of help them work out their strategy. They are thinking about a floating offshore wind competition to look at manufacturability in the UK. So hopefully there'll be more about that in the not too distant future. I think they recognise that probably the build out of offshore wind generally is slowing down a little bit, and we need to really look at ways to accelerate that to meet government targets. We're a minute over now, Rebecca.
You've done extremely well. I think we're going to have to draw it to a close there, but thanks so much, Simon, and for everybody for participating. Well, thank you ever so much for joining us. Welcome. For those of you who don't know me, I'm Rebecca Southern, Strategic Partnerships Director at Plymouth and South Devon Freeport, and I do have a croaky throat today, so do bear with me. I apologise. So as a Freeport team, we've been curating these lunchtime webinars over the autumn. Not something we've done before, but the idea is to invite our experts in our ecosystem to come and talk to a wider group about some of the things that are interesting and topical at the moment. And we're really pleased today to have Simon Cheeseman join us from the Offshore Renewable Energy Catapult. He's there waving in the corner. I think most of you probably know Simon. And I won't say anything about Oric because he's going to cover that in his presentation at the minute. But we as a Freeport team work closely with Simon. He's a font of knowledge on all sorts of stuff. But I'm going to read out his bio in case I get any of it wrong. So Simon is the Celtic Sea Floating Wind Programme. He leads that, driving collaboration across policy, technology and supply chains to accelerate the growth of floating offshore wind and marine autonomy. With extensive experience in both public and private sectors, Simon's been instrumental in advancing offshore renewable innovation and supporting the transformation of coastal communities. That about sum it up, Simon?
That's pretty good. I could recognise me in there, yeah.
Real, that's good stuff. So he's going to share his insights today on offshore wind ocean tech needs into the future. So he's going to do a talk and we'll have some time for Q&A at the end. But if you want to put questions in the chat as we go, that would be a really good gauge for kind of the areas of interest to pick up on at the end, if that's okay. So over to you, Simon.
Great, thanks very much, Rebecca. And hi, everyone. So I'm Simon Cheeseman from the Offshore Renewable Energy Catapult. Delighted to support Plymouth and South Devon Freeport with this series of webinars. I'm going to talk to you about offshore wind, bit about the Catapult, obviously, a bit about the market, something about the technology, then focus a little bit on the importance of marine autonomy, and then sort of zoom in a bit on the Southwest and the Freeport. If we've got time, an example project, and then a sort of summary. So I've got plenty of slides. You never quite know who the audience is going to be, so the slides are really set up for people who are sort of interested in offshore wind but perhaps don't know much about it. But I could try and sort of up the tempo a little bit in my sort of presentation, for obviously recognizing there's quite a few people with a fairly good sort of solid knowledge of offshore wind. So first of all, Catapult network and Renewable Catapult. So there are 9 catapults set up by UK government to establish or retain skills in certain sectors and markets. There's the cell and gene therapy catapult, connected places, which is cities and transport, compound semiconductor applications, digital energy systems, which is about the transmission of energy around the UK, high value manufacturing, medicines, ourselves, and satellite applications. So offshore renewable energy catapult, we look at, as it says on the